3 comma 0, right? You just plug it in. Yeah, at root 3, I'm going to be right here at the point 3 comma 0, so I'll label that t equals root 3. Where am I when t is negative root 3?
Other
3 comma 0.
Same place, right? Because right, this is just like an even, or no, I guess, I don't know, whatever. Yeah, same place. I'm still going to be there at, also at t equals root 3. Okay, so, sorry, at t equals negative root 3. All right, so this is kind of interesting, Stephen. This is more complex than, I don't think we ever did any curves in Precalc C that like cross themselves, right? This curve is going through this point like twice, yeah? And now can we just follow along with our like, I'm not going to draw anything. Let's just follow along, just follow my hand or something like that, right? Where are we going to be at time negative infinity, according to my sign chart?
Really far that way.
X is going to be really far to the right, and Y is going to be
really far down.
really far down, right? So I claim I'll be here I'll be down here somewhere at time negative infinity. And then what's the next interesting thing that happens?
Negative 3.
At time negative root 3. So yeah, so X is getting as t gets closer to 0 from the negative side, X is going to get smaller, and Y is going to get closer to 0. Then I'll be 0. So I'm going to be here at t equals negative root 3. Then what happens? Y becomes positive. X always stays positive. Then eventually at t equals 0, be at 0, and then Y becomes negative again, X staying positive, and then finally, because I'm not sure about certain things like curvature and stuff like that, so I don't want to draw. But essentially we're going some kind of way, right up. Okay, so that's pretty cool. And so this curve crosses itself. Well, I would like to know in what way it crosses itself. So now I have some questions. And the questions are, what's going on at t equals plus or minus root 3? So what I would like you to do right now is to find the slopes. So here's our first question. Find the slopes of the tangent lines to the curve at the point 3, 0. Well, how should we do this? If I want the slope of the tangent line to the curve at the point 3, 0, then I need to figure out what like dy dx is, right? Am I going too fast? Too bad. We have to finish this problem. Okay, you obsessed no representative person in this class. So yeah, let's do it. What is dy dx? How do I compute dy dx? dy dt dx dt. Okay, what's dy dt? 3t squared minus 3. I agree. And what is dx dt? 2t. Ta-da! This is now a formula in terms of t, which will compute what the slope of the tangent line to the curve is at that point. Cool? Okay, and now I simply just compute, all right, if that's the formula for dy dx in general, what is dy dx at t equals root 3?
Root 3.
Oh, yeah.
Yep. Depending on your arithmetic speed, plug in root 3, squared is 3, times 3 is 9, 9 minus 3 is 6, 6 over 2 root 3 is just 3 over root 3, 3 over root 3 is just root 3. Are we cool?
Yeah.
Yay! All right, what is dy dx at t equals negative root 3?
Negative root 3.
Yeah, I think it's just the exact same thing except the bottom will be negative now, right? So this is just going to be negative root 3. Okay, so I've learned a valuable thing that I never would have known without calculus, which is that as I come back up through this, or as I come through this point 3, 0 for the first time, my tangent line is going to have a slope of negative root 3. And as I come back up again, my tangent line is going to have a slope of positive root 3. Cool? So I'm like drawing in the tangent line such that I may make an accurate curve. Okay, next, find the places on the curve where there are horizontal or vertical tangent lines. Horizontal or vertical tangents. Where are those? Well, let's do horizontal first. Where do I have a horizontal tangent line?
T equals 1.
-1 and 1.
Negative 1 and 1.
Yeah, whenever, I'll have a horizontal tangent line whenever dy dx is 0, which is going to be whenever the numerator is 0, which is going to be at t equals plus or minus 1, right? Is everyone okay with that? I hope you are. T equals plus or minus 1. So how about at t equals 1, where am I?
1 and negative 2.
I'm going to be at the point 1 comma
Negative
1 minus 3 is negative 2. All right, and how about at the point t equals negative 1, where am I going to be?
1, 2.
Should we trust him?
Yeah.
Yeah. 1 comma negative 1 plus 3, yeah.
2. Let's do the same.
That's 1 comma 2. Okay. And now how about vertical tangents? Where am I going to have a vertical tangent line?
When t is 0.
Yeah, I'm going to have like a vertical tangent line whenever this slope is going up to like infinity, right? Which will happen when t is 0. Kind of, right? At t equals 0, I'm going to have like, sort of like an infinity. So yeah, so that's going to be at t equals 0, and we know that at t equals 0, we're at the point 0 comma 0. Okay, so this means that I'm getting like a pretty accurate graph here, right? At time t equals negative 1, I'm at the point 1, 2, and here is like this. And so continuing to draw on these little guidelines, I know that I have a horizontal tangent here and here. Sorry, what did I say? Here and here at t equals negative 1. I'm here at t equals 1. And I also know that that I have a vertical tangent at 0. All right, so this thing is starting to come into shape. All right, the last thing is I'm interested in the shape of this parametric curve. And thus what I'm interested in is concavity. All right, so what's going on here? This is confusing a little bit. So I might like recap this explanation next class, but I'm interested in concavity. And when I'm interested in concavity, I'm interested in what the concavity is determined by what the slope of the tangent line is doing. So here is my tangent line, and what I want to know is my tangent line kind of curving downward, or is it kind of curving upward as I change x by a little bit? And so if you think about this for a while, what it turns out what we really want to know is what is the derivative with respect to x of dy dx. You don't even necessarily have to use the word concavity, and maybe it's better if you don't, but if you think about it, if we can somehow compute this, also known as this terrible thing that everyone hates, but I love it. This is saying, what is the derivative with respect to x of dy dx? In other words, if dy dx is the slope, if x changes by a little bit for this particular t value, if I scoot over a tiny bit in the x direction, is the slope of the tangent line getting bigger, or is the slope of the tangent line getting smaller? Is everyone cool with this? All right, how do I actually calculate this, however? That seems kind of hard and weird. Well, it's like this. So if we take this problem that we kind of did already over there, which is, yeah, I guess we're just doing this here now, right? So what I really want, I want the derivative with respect to x of dy dx. Well, what is that? Well, for example, on this problem from the backboard, dy dx, we determined, was 3t squared minus 3 all over 2t, right? Okay, so this dy dx is in fact just another function of t. All right, so temporarily, to avoid confusion, let's just give this a different name. Let's just call it like z or something. right? So let z be 3t squared minus 3. That's just like my temporary nickname for whatever dy dx turned out to be. Yes?
Oh, can't
Pause.
we just like use the equation x equals t squared and like plug it in to replace
No,
the
watch.
t?
Just stay with me for a second. So this is this, right? So what I really want, if what I really want is the rate of change with respect to x of dy dx, then what I really am just looking for is, well, what is dz dx basically, right? Because by temporarily calling this z, what I'm interested in is the rate of change of dy dx with respect to x. Okay, so if you're okay with that ish, then what is dz dx? dz dx is, well, z is actually a function of t, and x is actually a function of t. So for all the same reasons over there that this chain rule was needed, this turns out to be the same thing, right? This is going to be dz dt over dx dt. Do at least some people find this mostly reasonable and plausible? Stephen, you okay? Yeah? Okay. So it turns out that if I want to compute the concavity of one of these parametric curves, what I need to do is take the derivative with respect to t of dy dx over dx dt. If you kind of write that down and stare at it for a little while and think about it, I think it'll make sense to you. And if not, I might try this whole explanation over again a little bit slower next class. But that's pretty good, right? Yeah, I thought it was good. All right, so that's helpful. Okay. All right, so let's actually do it for this problem. Let's examine the concavity for this problem here. All right, so that's what I want. I want to know the derivative with respect to x of dy dx.
Just ask your opinion.
Okay, so going really fast now, what that means is I need to compute the derivative with respect to t of that thing over there, 3t squared minus 3 over 2t, over dx dt. Okay, so let's just, everybody take like 45 seconds and do that numerator, I guess via the quotient rule. Ah.
Good afternoon, Blazers. May I have your attention for some brief
so do you guys get what I
announcements?
got?
Baseball,
So
softball, and
simplifying
tennis games
this,
for today have
I
all
get
been
12t
canceled.
squared
Please see your coach for updated
minus
information.
6t squared
Volleyball
plus
plays
6
today. Our
over
boys
18
take on
cubed. Is that what you got?
Wheaton here at Blair
So
at
back me
5
up.
o'clock, and the
So really
co-ed
this
team
turns out
follows
to
at
be
7 o'clock. Please come out and support our
6t
volleyball team. They
squared
would love
plus
to have
6
you
over
at their
18
game here
cubed.
at Blair.
Tell me something about this
Also,
fraction.
congratulations to our
Numerator.
varsity softball players that defeated Walter Johnson and Quince Orchard over spring break. And congratulations to our varsity and JV girls lacrosse players that defeated Paint Branch yesterday.
Always positive.
Numerator always positive, says EO. Denominator,
prep course at Blair beginning Tuesday, April
sign change at
28th.
0, and
To prepare for the
specifically,
game
what's the sign chart for this?
This is a
It's gonna go
5-week
like this,
course
right?
that meets 2 times a week from 3:30
Alright,
to
this is really kind of
6:30.
fast and rushed, and I'm
Typically,
rushed
this
and I'm
class is
fighting with
offered at a cost
fuss,
of
but basically,
$699.
what I've
For Blair
concluded is that
students,
this function is
Kaplan is making this
concave
class available at a
down
cost of
on all
$325.
negative t values
Registration
and
forms are
concave
available
up
in the
on all
counseling and main
positive t values.
offices. The deadline
Alright.
for submission of
The
both
grand conclusion is
applications
we are going to
Friday,
graph this
April
function. Are you
17th.
ready?
Please see Mrs. Blackie in the main office
Okay.
if you have any questions. Thanks, Blazers, and have a great afternoon.
Good. Where am I in time? Negative infinity. We agreed that we're down here somewhere, right? So I start down here, and then what happens? I'm concave down on the t integral from negative infinity to 0. So I'm going to swoop up, crossing through the point 3, 0, with slope negative root 3. I'm going to come up here. I'm going to have a horizontal tangent. Then I'm going to have a vertical tangent at 0. Then I'm going to have a horizontal tangent at 1. And then I'm going to cross back through the point 3, 0 with a slope √3. Yes, it's like a Jesus fish thing, right?
What?
I don't know what the actual name for that
Or else.
object
I
is.
think it is called,
Or else.
I think it's called a Jesus fish.
I think it's called a Jesus fish, right? Is that an actual name or that's not what it's called? What's their name for it? It's a fish.
Symbol is how
It's the thing that people have on their
like
books.
a Jesus-related symbol.
Good. Time to, everyone get it? Can you do problems like this, you think? Good. Class over. And you will have some homework on this topic by internet. See you all.